I think what we're going to do is I've got slides. I'm just going to kind of go through the slides. This is a hard chapter to teach. It's probably one of the most difficult ones, just because joins are very. I mean, this is sort of the pinnacle. I mean, it's only chapter 4, but I mean, as far as sophisticated queries go and difficulty of queries, joins are kind of up there at the top. So a lot of the slides have, a lot of what the slides do is we show you queries and we talk about those. So I'm going to limit it to some of the less difficult queries, just because when they get, when you start joining two or more, there's some examples of 3, 4, and well, I think max they had 4. They have one couple of queries that show joining 4 tables. It's just beyond, or at least for me, from a teaching perspective, to be able to sort of talk through it. You're so far in the weeds that um, I just don't know that there's much value there. Um, so we're going to look at slides, and then we're going to experiment with some queries live. We'll see how that goes. But I've got a couple of sample exercises queries, and I can probably maybe I'll try and cut and paste some of that in the some of that into chat, and you can paste that into your console if you don't want to. And I don't know. We'll try it and see. You may be able to hand type. I know that anytime you're just sort of typing queries out from scratch like that, it's so easy to fat finger things. You often it's I found as instructor, I'm not hand typing things out. I've already ran these quick queries prior to you all running them, just so I know that they work, and I'm not sitting here trying to kind of fumble through things. So I'm going to be cutting and pasting queries that I know works. If you are trying to type from scratch, I know it's often easy to get lost when you're doing that, and folks get behind. So anyway, we'll see how that goes. All righty. So somebody shout if you can't see that, but we're we'll we're going to look at, how to retrieve. Chapter 4 is how to retrieve data from 2 or more tables. Let's play. Nope. Yeah, we're just going to have to do it like this. How to retrieve data from 2 or more tables. Here are the objectives. Basically, the big thing we'll be talking about is inner outer joins, and then we'll talk about left and right joins too. Again, not I'm going to keep it relatively light. There's just a handful of slides here, and then I've got a video I'm going to sort of show that I think is going to help explain things to here. So when the time comes, I'll play that, and yeah. Alrighty, so let's start out with, this is sort of an explanation of the syntax. So if you recall, if anything that's in these brackets are going to be optional. So in this case, the select and the from should make sense at this point. The vast majority of the queries you're going to run all have that sort of select and from statement. So we're going to select the list of attributes or columns that we want. We're going to specify the from specifies which table we want, and then we get into this inner, and we'll see examples of outer and left and right joins later on. But and again, these are optional statements, and then join on particular tables you want, and then you've got this on statement too, and that on is just specifying in this case the join condition is the term that they use. And join condition is basically the specific column that you want to join on. So the second example they've got here is a real, is an actual live query. So in this case, select, we're going to return invoice number and vendor name. Of course, you can see those are the 2 columns here. So select invoice number and vendor name from vendors, and then we're going to join, interjoin with the invoices table. So these are the sort of 2 tables that are the 2 tables we're going to be pulling data from. And I'm going to show you this video in a second. You can think of it like a Venn diagram in your mind, sort of put the tables side by side and then overlay them on top of each other. And that sort of section in the middle where they overlay that. That's the actual data that gets pulled and displayed. So in this case, it's going to be the vendors and invoices table, and then we have to specify and be explicit about which column we're going to be joining on. Like the way to think about that is which which column the two tables have in common, right? So in this case, both the vendors and the invoices table have this vendor ID, or have this vendor ID column. So that's what we actually join on. In this case, we're adding an order by statement then. Of course, that order by statement is optional. We don't have to have that, but again, it just orders the data in this case in descending order. And then so you can see the results that you get from that query. Let's go ahead. So let me just pause here now. Let's go ahead and look at the. Let's go ahead and watch this video. And the reason I like this is because again, it gives you this visual of sort of overlaying tables on top of one another. I don't think I shared my sound, so let me share again. And I want to share sound. You can hear it. Ooh. Getting don't think it's going to cause me to restart. Hopefully it won't. Let me stop share and reshare again. Share sound, share. Alrighty. So hopefully if the sound's not coming through, you can't hear it, since somebody shout.
MySQL. A join is a clause that is used to combine rows from two or more tables based on a related column between them, such as a foreign key. Here's an example. I have two tables, a table of transactions and a table of customers. Think of these two tables as a Venn diagram. Transactions will be the table on the left. Customers will be the table on the right. Whatever data they have in common is the middle part of our Venn diagram. For my demonstration to make more sense, I will need to add a few extra rows. Feel free to pause the video if you need to catch up. I will insert into transactions a new row. The amount is $1. The customer ID is null. So not all transactions can have a customer ID, that foreign key. Here's a scenario. Suppose that somebody comes in, pays for a soda with cash. Well, we wouldn't have a customer ID, right? If a customer instead paid with a credit card, we could track who that customer was. There may be a customer ID who initiated that credit card charge. I'm going to insert this row, and here's our new transactions table.
Just real quick, notice the fact that they've got null values here, and that's again when you think about these two tables side by side. Some rows, some columns could potentially have null values in them, and so often when the data gets returned from these joins, the rows that have null values in them will be left out of the query results. And potentially too, if there's a null value in one of the primary key fields, which is going to be rare, you're almost never going to have that happen. In fact, that almost always breaks MySQL rules, but those rows would be left out also.
Not all rows have a customer ID. Then let's add one more customer. Insert into customers, first name, last name will be Poppy Puff. Let's select all of our customers. Now, not all transactions have a customer ID, and not all customers have ever initiated a transaction. They could be registered as a customer, but they have never actually bought anything yet. Using joins, let's take a look at what data these two tables have in common. We'll discuss inner joins, left joins, and right joins. Let's begin with an inner join. To create an inner join between these two tables, you would type select all from which table would you like to be on the left? Think of that Venn diagram. Our transactions table will be on the left. From transactions, inner join whatever table you would like to be on the right. In this case, customers. On, we're going to join these two tables together by the foreign key from transactions. We'll take transactions dot the name of the foreign key column, which was customer ID.
Let me pause here and talk about this dot notation. Often when you see these dots like this, that the common term for that is called dot notation. You see that not only in MySQL, you'll see it in object-oriented programming too. So if you've had C++ or uh, Java, that notation should be familiar to you. In the case of object-oriented programming, it often refers to an object name and then the dot and then the attribute that might be associated with that object. In MySQL, similar. It's from from a mental model standpoint similar. In this case, it's the table name is on the left and then the column name is on the right. So in this case, you see here example they're using transactions.customer ID. There again, there's a customer ID column or attribute inside the transactions table. So that's kind of how that works. But anyway, that dot notation, just sort of keep that in mind. Again, if you stay in software development, IT in general, at least on the data side of things, that dot notation is a common idiom you'll see.
Equals the table on the right, dot the name of the primary key column, which was customer ID. Then we will execute this statement, and here's our new table. We have created an inner join from these two tables based solely on what they have in common. If you remember, we don't have that row for that transaction for $1 that doesn't have a customer ID. As well as our customer Poppy Puff, there's no row for her in this table. What we're telling MySQL is to select all rows from these two tables that have matching customer IDs. So that's why some data was excluded. One thing you could do with a join, this applies to left joins and right joins as well. You don't necessarily need to display every single column from both tables. You can select specific columns. Let's select our transaction ID, the amount, the first name, then the last name.
Just real quick before he actually runs this query, notice, let me go back. Yeah. It's often nice to see all of the data that gets returned, including the duplicate data. In this case, again, we're joining on customer ID. The customer ID column is in both of those tables. If you're joining on that table, it stands to reason that you're going to see the exact same data in both of those tables. So it's a bit redundant, right? You don't necessarily need to see it. However, just from a testing standpoint, it's often nice and exactly the way he did it here. Go ahead and return all of that data just so you can sort of sanity check. You've got a visual sanity check that, okay, I'm seeing customer IDs for all of the data that gets returned and then all of the other things. And then he's kind of moving to a quote unquote cleaner version of this. And again, think of a scenario where you might be creating a report for non-technical folks, management, somebody like that. A sort of cleaner version of the data would be one kind of like he's about to do in this next query, where you remove some of the columns that are not needed or from someone who's going to consume the reporting data might be kind of superfluous, right? Right. You don't necessarily need to see the customer ID.
The first name, then the last name. This would make it a lot easier to find the first and last name of who initiated a transaction at a given time. We know who bought which order. So that is an inner join. Join together any matching rows based on some link. In this case, we're joining these two tables together by their customer ID. Now with the left join,
I'm going to pause there because we're going to talk about left joins, and then we'll come back to the video. Any questions or observations about that? Okay. And again, think about the receipts that you get. I mean, what I was thinking about when I was looking at that is, when I get a receipt from Walmart, Walmart has this technology now. When you check out, you can have it email you. I think you can put your phone number in, it'll give you a link, and then you can tap on that link, and you get this nice output of. In fact, I'm trying to think what I did. I did something interesting. It wasn't SQL, but I think I used ChatGPT AI to do it. You could download you could download a version of your receipt. Then I actually uploaded it. I can't even remember why I did it. If it was just for kicks or I was looking for something specific, but I actually uploaded the receipt and said, "Hey, tell me where my money's going." I mean, this was a big. I mean, there were probably 30 items that I had purchased there. But anyway, from a reporting standpoint, again, think about the results we got back in that query. That looks similar to what you might see in a similar to what you might see in a receipt that you get from the grocery store, right? You've got the name of the product, you've got the quantity there, you've got the price. Um, all of those are queries. I mean, all of that. Think about the database query that's happening behind the scenes when you get a receipt from the grocery store. Not only that, but think about the quantity of think about the quantity of queries that are happening. Think about all of the people. Again, just use the example of Walmart. Think about the hundreds of thousands, if not millions, of transactions that happen at Walmart each day. You know, think about it again, and so it's probably safe to say that there are, you know, that it's in the millions of customers each day who visit Walmart and check out and create a receipt like that. You know, all of that data is stored in a database somewhere, and there are queries going on. Again, hundreds of thousands, if not millions, of queries that are happening each day. Not even each day, each hour of the day, right? And so it's pretty kind of mind blowing. The other thing is I tell students this too, that hopefully, I think after you take this class, you really do start to think about the world in a different way. Again, whether you visit the grocery store or Walmart or all of the transactions you do online, you know, you start to think in terms of databases and database transactions and how all of that stuff is happening in the real world. Okay. So let's look at this is inner join that uses table aliases. Just know that table aliases are a thing. The purpose, it doesn't change the results of the queries, and it really changes nothing about the query other than it's generally easier to read for human beings. When you're explicitly using dot notation to reference a lot of the attributes, it can get the queries can get onerous as well as they can just be more difficult to read. So just table aliases makes it a little easier for us as humans to be able to read. Here's an example. So here we're selecting an invoice number, vendor name. We're actually adding some math, some arithmetic here for one of the fields that gets returned. In this case, we're going to call it balance due. So you can see that here. And now the other thing is that so now we're using the table aliases here, V and I. So from vendors V, all that does is that, you know, and again, this V, we could call it anything we want. Vendors V, invoices I, and then notice in our dot notation here, we're able to say V dot vendor ID, I dot vendor ID. Again, not a huge deal here, but, you know, think about it in terms of often the column names can get very long. You might have invoices underscore with underscore taxes. Let's say I'm just making something up, but, you know, really long column names, you can use the aliases to shorten those out into, you know, in this case, they just use single letters to do it. So just again, makes your queries much easier to type. Inner join with alias for only one table. You know, and again, invoices, and again, you can see an example here. This is an example of, you know, the longer column names that I talked about in this case, invoice line items. Syntax uses qualified database name or qualified with the database name. Yeah, again, that's just an example of the dot notation we looked at. So in this case, we've got an inner join with two conditions. We'll go back and look at the tables here and see if we can sort of make the connection and the data that got returned. So here we're selecting customer name and first name from the customers and employees table. And then we're going to join on the customer's first name. And so again, just we're mixing in some of the conditional statements here. We can do on, or we're using the and. I'm using the and condition. So we're joining on customer's first name and customer's last name. And then the result we get here is Thomas Hardy. And so we see Thomas Hardy is up here at number 4. Thomas Hardy does not get returned here. So I think that's why he actually shows up in the join statement, because it's the only that's the only customer that shows up there. Self-join that returns vendors from cities and or self-join that returns vendors from cities in common with other vendors. So this idea of a self-join, notice we're actually joining data from the same table. So the way you can envision this is, and again, we're using the vendors table here. So imagine 2 copies of the vendors table in this case, and then sort of laying those 2 tables on top of one another. In this case, we're doing select distinct. So we're removing any duplicate data from the results that we might get. So select distinct V1 vendor name. So vendor name and vendor city and state is what we're selecting. Of course, we can see those 3 columns at the bottom here. So from vendors V1, and then we're joining that on vendors V2. So again, same table, the vendors table. Notice we're using the alias to actually give each of the tables a different names. In this case, V1, vendors 1, and V2. And notice in our on clause here, we're doing so V1 vendor city. So where the city is in both tables, where the state is in both tables, and where the name is in both tables. And then we've just got an order by clause that we're that we're adding to the end. And then you can see the result. We can see the result that we get here. Also noting that there's no duplicate. There's no duplicate rows here. That the distinct statement gets rid of those. I just left this one in, and again, I'm not going to walk through this, but this really just shows. I really left this one in just to show you how sophisticated that we can get. Way more sophisticated with these joins. In this case, they've got 4. We got 4 tables we're joining. I want to move on to the right and left joins. Let's go back to our video and let's have that. Let's let it walk us through left and right joins, and then we'll come back and look at some examples.
We are going to display everything from the table on the left, but let's select all. With the left join, we will display everything from the table on the left, our transactions. However, if there is a matching customer ID, pull in any relevant data from the table on the right. Even though there's no customer ID with this latest row, we're still going to display it with a left join, but there's no data to pull in from the right table because there's no registered customer ID. With the right join, we will display the entire table on the right. If there's any matches, we will pull in any matching rows from the left. We are displaying all of our customers. If any of these customers ever initiated a transaction, we will include the data from those transactions. We still have Poppy Puff in our table, but she has no relevant transactions. She never initiated one. So yeah, everybody, those are joins. A join is used to combine rows from 2 or more tables based on a related column between them, such as a foreign key, like customer ID. And that is a quick introduction to join.
And again, something to note, he didn't make note of it here, but that you have null data in left and right joins. That's often when you'll see null data can potentially get returned. And again, that's a feature, not a bug. However, it's just good to know because depending on what you're doing with that data, where you're displaying it at, null values can often give you issues. So let's look at an example they've got here. So in this case, a right outer join. So select department name. In this case, we're selecting department name, department number, and last name from departments, and then right join on employees. So again, think about the departments table, employees table. We're doing the right join so that the data from the employees sort of side of that is what's going to get displayed where there's matching data with the left table. So again, right join employees. We're joining on department number. So again, both the department and employees table have a department number column, and then we've got a simple order by statement there. And again, notice we've got some null values that got returned here in addition to the other data. Using is handy. To be honest, I don't have a good sense about how often using is used, but it can make more logical sense just when you're reading through the query. Let's look at an example of what they've got here. Using just as an explicit way to identify which column you're joining on. And it basically replaces the on clause that we saw in previous columns where we say we're joining on a specific attribute or column name. Instead of using that syntax, we can use the using keyword to do that. So in this case, select invoice number, vendor name from vendors, join invoices using, and then in this case, we specify vendor ID. And then, of course, we've got an order by statement there. And then notice we get this data return. So again, this just the using keyword is explicit way and kind of a replacement for the on keyword. Using with 3 tables. This is not terribly complicated. The department name, last name, project number from departments, join employees using. So again, department number is going to be the common column name. And then in this case, we're doing a left join on projects using employee ID. So you've actually we've got 2 common. So again, department ID or department number, all 3 columns are going to have in place. In this case, we're also pulling out the employee ID from the projects table. And then, of course, we've got an order by statement here too. Last slide here, just common terms. We didn't cover all these, but again, outer join, left join, right join, equijoin. We didn't talk about these other ones. Just really want them here just so you sort of know that they exist and that it's a thing sort of outside the scope of the class, so we're not going to cover that. I think the book talks about those, so just know that they're there, although we won't be using them here in class. Gregory, you had your hand up?
Yes, thanks. A pretty basic question, I'm sure, but if you say go back to slide 15, where it says right join employees, can you explain what employees is in this? What's that referring to?
So it's just the employees. It's the employees table. So in this case, we got in this case the tables that are involved in the query overall, both the departments. Yeah, it just looks like there's just 2, the departments and the employees table. So and then they share this department number. Both the department and employees table have a department number column, and so that's what they're being joined on.
Okay. After you join, are you making a table with a new name?
So you're not making a table. This is purely results, right? This when you run this query, you're going to get the results that you see here. It's not a table though. It's just results.
Okay, so in that one, you're naming the two tables and then just getting results. Okay, thank you.
Yeah, and you can, in fact, but that is just a good whole point of note there. And I'm not sure which chapter we'll cover that in, but you can actually create tables from results like this if you wanted a new table created. But yeah, in this case, yeah, we're not creating anything new. These are purely just a query. I mean, often ad hoc is the term that you'll use, and ad hoc means that generally what that means is that you're just sort of doing it on the fly. You're not creating anything new. Nothing's getting saved to the database. It's just purely the results that you see on the screen. Okay. We're going to move on to some exercises. Any questions before we leave this?
Could you explain the foreign key again? I'm sorry, I'm just a little bit fuzzy on that.
So foreign keys are, I mean, there's a couple of things around foreign keys. The biggest thing about a foreign key is it's a unique identifier for a row in a table. So there's only one, and in fact, let's look at some. I'm gonna have to log in. Let me make this big. So let me log in here. I'm just going to use Zachary's database. We're not going to be modifying anything. So show tables. So for instance, if we look at the invoices, let's look at the terms table. Select star from terms, limit 5. So notice you've got this underscore ID. So generally your primary key, a second, let me call. Sorry. Generally, your primary key, couple things. Number one is generally the first column that you see in. It's the first column that you see in a table. The general format of it is it's going to have this underscore ID. That's not always the case, and it's not a rule. You can name a primary key column anything you want, but sort of the generally accepted way to do it is to use this underscore ID. And again, the idea here is this is a unique identifier. For any primary key value, that value should be unique for that column. Now, in this case, we don't have any duplicate data. Invoices might have. Let's see if we. Yeah, it's not. Well, I mean, yeah. I mean, if you notice here, we've got duplicate values in credit total, right? There, there's zeros all the way down. So in that case, in that case, you can have that. But invoice ID is always going to be unique. Now here, the data is kind of skewed, so we can't see. Well, yeah. I mean, in this case, this 1 here, 2, 3. That's your that's your invoice ID, which is your primary key. And again, the idea here is that has to be unique, right? Every row has to have some unique identifier because when we're writing queries to call data from different places, and I think I used a word in the first class, I mentioned something being ambiguous or ambiguity. We can't have any ambiguity in the queries that we write. So when we're selecting data from a particular row, we have to be explicit about the row we want. If we had duplicate values in a primary key, when we went to call data from a particular table, we might have some ambiguity in that query, meaning that if I say, select star from invoices where invoice ID equals 1. And if we had more than one row that had a 1 in it, then that would be an ambiguous statement, right? Because we wouldn't necessarily know which specific row we wanted to get returned. So again, unique value, unique value that specifically identifies a specific row in a given table. We can have duplicate primary key values from different tables, but within a specific within one table, you can have only one value for a primary key. Does that make sense? Okay. All righty. Let's try some queries. So if you have, you're welcome to follow along with me. I'm going to pull up a text editor because it's just going to be easier to do it that way. And again, this will give you a sense. This is how, I mean, I'm assuming you all are probably working this way too. Often it's easier to easier to manipulate and write your query inside a text editor locally first, and then paste that into MySQL to actually look at what the results are. Okay, so let's try. What I'm going to do here, and I'll paste some of this into the text editor so you can see it. I may paste some stuff into text too, but let's see how this goes. Okay, so the first task I'm going to give you here is, let me put this in here. Let me resize some things. Let me make this a little bigger, maybe too. All right, so first one, let's try and do, let's show each invoice with its vendor name and payment terms, okay? Now, often what I like to do is, like, the first thing I'm trying to do here is, okay, when I see a requirement, let's just use that term. When I see a requirement like this, and again, put yourself in the shoes of, let's say you're a database administrator and you're working with sales or management folks, and they say, "Hey, Mark, we need to see all the invoices. We need to see all the invoices along with the vendor name and the payment terms." Now, first thing I would say, if someone asked me for this, it's okay. Tell me specifically what data you want, because when you say I want to see each invoice, we just saw in the query around here, the invoice has a whole bunch of stuff. So, first thing I would say, now they probably don't want invoice ID and vendor ID. For, again, let's imagine these are non-technical folks. They're not going to want that, but do they want the invoice number? Do they want the invoice date? Do they want the invoice total? What exactly? So oftentimes when I get requests like this from non-technical folks, and it's not their fault, it's not they're not being they're not being sloppy about their request or something like that. They just don't they're not technical, so they don't know all the information that's available. So when they say I want to see the invoice, I would say, well, tell me more about exactly what you want to see. The vendor name part is pretty straightforward. The vendor name is a field inside the vendor table, so we're okay there. Payment terms might be a little bit ambiguous, so we'll have to see about that. So those are the things that I would think about when I would get a request like this. The next thing I would say is, in fact, yeah, let's just sort of write these down. First thing I would say is, what portion of an invoice. So there is a question there. Next thing I would ask myself is, okay, and this is just purely from what I'm starting to think about, okay, I want to actually build this query. What tables are involved? All right, and let's go ahead and answer that question right now. So what tables are involved? So just think for a second about this query. Well, the invoices table is most likely going to be involved. Invoices, the vendors table, because we want to show each invoice. We want to show its vendor name And then we want to show payments terms. How about payments term? What table? So I'm in the AP database right now. I'm going to say show tables. And yeah, I have a terms table, right? So most likely our payment terms is going to be we're going to need to use the terms table to find that out. Okay. All right. Now, so there's that. We also know this is going to be some kind of join. We know this is going to be some kind of join statement, right? Just from the fact that there are multiple tables we're going to need to pull from. The other thing is, what's the common data in all of these tables? And when I say common data, I mean we know we're going to need a join statement. So we're going to need there has to be some common data in all of those tables that we can join on. And in fact, if I scroll back up, if I look in the invoices table, and in fact, let's do that now. Let's do, in fact, not sure if you've used this yet, but there's a describe statement we can run. So let's do describe invoices. And then let's do describe vendors. And then let's do describe terms. All righty. Now, unfortunately, we can't sort of get all this on the screen at once, but let's look through what we've got here. So terms, we have a terms ID and we have a description and due days. Vendors, we can look at the data we've got there. And then invoices is up here. So now the first thing I see is that our vendor ID is a common field amongst, and again, these are our primary keys or sort of shared primary keys. In this case, in the case of the vendors table, the invoice ID is going to be the primary key. And in fact, let me highlight this. If you notice in this under key, I've got this PRI. That means it's the primary key. And then notice I've got vendor ID here. I've also got vendor ID inside, obviously, inside vendors. So that's going to sort of be our shared key. We're most likely that's going to be a part of our join statement is using that vendor ID. Now, how about terms? It's sort of the terms table itself doesn't have a common field with any of these other tables. However, our invoices table has a terms ID, right? So again, if we were sort of drawing, if I had we haven't covered or used entity relationship diagrams yet, and these are kind of, you can think of them almost like flow charts, but again, we'll get into those, I think chapter 10 when we get into database design. But you can imagine drawing a line from this terms ID up in invoices down to the terms ID field here. So we've sort of got enough common. Just looking at everything I'm seeing here, I'm feeling pretty good about our ability to write some kind of join statement that's going to join all of the data here and allow us to write this query. Again, the query we want to the requirement we're trying to fill here is, again, show each invoice and one vendor name and payments term. I'll pause right now and see if there's any questions. Okay. All righty, let's start to build our query. So really the first thing we're going to do is we want a select statement of some sort, right? And so part of our select statement is going to be, we have to ask ourselves, well, what fields do we want? Again, we already said there's a little bit of ambiguity around what fields from the invoices table we want, but we're going to go ahead and make some decisions here. So in this case, I'm going to select invoice number, invoice date, invoice total, vendor name, and then terms description. And this should satisfy just these fields. Let's not worry about the join statement yet. Again, these are just the fields from the various tables we're going to pull, from. And again, so invoice number, invoice date, invoice total, that's all from our invoices field. And in fact, if we go up here, so yeah, invoices number, invoices date, invoices total. So these are the three fields we're going to pull from the invoices table. And then vendor name, that was part of our requirement. We can get that from the vendors table. And then vendor name, and then terms description, we can get that from the terms table. Okay. All right. So now that we've done that, we have we have the fields that we want. Our from clause is going to be the next thing. So we're going to select this data from where. Now, again, you can think about this. We've probably got some flexibility in where we want to pull from. The invoices table kind of makes sense because, again, that's where the sort of primary key field that we're pulling from is. In this case, the invoices ID or the vendor ID is sort of the common between. Yeah, and so in fact, yeah, we sort of talked about that some, but the vendor ID is the common field between these. So because they are, we're going to start out with the invoices table. So we're going to say from invoices, and we'll use an alias here. We'll just say invoices I. And then we're going to actually type our join statement. In this case, we're going to join on, we're going to join with the vendors table. So vendors V. And then we do our on statement. In this case, we're going to join on the vendor ID field, because again, that's the common field between those two. So in fact, we do I dot vendor underscore ID equals, and we'll do V dot vendor ID. Now we could, let's see if we can run this now. I'm curious. Now we haven't added terms. We've still got to get our terms in there, but let's just see. This is complete. No. Okay, no. Okay, well, let's, yeah, let's remove terms. Yeah. Okay, there we go. Let's limit that, limit 5. The reason I'm doing this is, and again, this is a personal preference, but I think it makes sense. I suspect most people that are, would approach this would do it the same way. I'm sort of taking an incremental approach with regard to the complexity, right? So again, we're going to bring the terms in. That was a part of the requirements that we want. We need payment terms. But before I add that in, I've sort of got enough just between the two tables. It's nice to say, okay, let me pause here. I've got a query that's sort of partially built, and sort of take this incremental approach to say, okay, let me pull in, in this case, I'm getting invoice number, date, total, and then the vendor name. Let me just run that query and just sort of sanity check that, that's returning data and it works. And then I'm going to go back and add a little more complexity to it. Let me check the chat here and see. Can you explain? I think we answered that earlier. So yeah, I think we're okay there. I'll pause though. Any questions?
Can you paste what you have into the chat so I can see?
Yep. Thanks for mentioning that. So I'm going to do that, and then I need that on the end. Okay.
Can you explain again a little about how the ambiguity ID and how you're looking at that when you're deciding
Yeah,
what to filter?
let me think here. Let me look at what we've got here and see if I can make a connection. In this case, let me just print out, I'm going to add I dot vendor ID. See if this may or may not be helpful, but I'm going to give it a try. And then let me limit. Okay. So in this case, we're printing out the vendor ID. Actually, let me do. Okay, this may make sense. Notice here I've got duplicate vendor ID keys. Now you may be saying, wait, hold up, why is that? Well, the reason that is because in the invoices table, in the invoices table, invoice ID is the primary key, so it's the only unique key. Vendor ID is not. There are multiple, there are a list of vendors we're looking at, and that the same vendor can show up multiple times. The same vendor can have multiple invoices, so that's why it's not unique here. You would say there's no ambiguity there. However, if I do none, and the reason we're seeing when I ran this query, the reason we're seeing vendors with the same ID here is because I actually pulled vendor ID from. Notice I did I.vendor ID. Now, if I do, in fact, if I do v.vendor ID, I'm curious to see what we get here. Yeah, we still get multiple, so that's actually not a good. I sort of had a thought in mind, but again, with regard to this query, I don't, Gregory, I'm not coming up with a good. Hopefully, let me continue to think about that, and if I see a good opportunity to talk about where having an ambiguous query would be an issue, I'll do it. But I'm not seeing a good opportunity to sort of show you that now. Yeah. Okay. So let me go back. Let's let me see if let me make sure we're back where we. Let's do limit 5. Okay. So here we are, and so the last thing we need to do is we need to add our payment terms here too, right? So again, the idea here is I'm sort of taking an incremental approach rather than sort of trying to take a big bite out of the apple in one bite or one chunk. Let me sort of break this down into smaller queries. So in this case, I've got a join on the vendors and the invoices table, and I'm returning the data that they asked for here, which is again the invoice and the vendor name. Now I need to add payment terms in there also. So let's add another join here. So now we're going to go join, and in this case we're going to add the terms table. Terms has we want a payment terms. I think we said we were going to use the terms description. I think might be what it is. So we're going to do terms join terms T on, and in this case we need. So let me run our describe statements again. Let's see if we can go back up and look. So I just want to go back to our terms table and see what the common field is. So again, our terms table, we've got terms ID, description, and due days. And in our vendors table, we've got our in our invoices table, we've got terms ID. So that's where, so again, in the current query we're getting a list of invoices that are returned. So we need to basically go and say, all right, from the invoices table, we also want to grab this terms ID. And from that terms ID, we're going to trace that back to the terms table, and we're going to return terms description, right? So let's see what that looks like. So we're going to do join terms, and we're going to do the on statement is going to be on I. So terms ID exists in the invoices table. So we need I.terms underscore ID equals. So where else does terms ID exist at? It exists inside the terms table. So we'll use the T alias here. So T.terms underscore ID. And let's just stop there. We can the sample solution I've got has an order by statement, but let's not again. We want to again taking this incremental approach. Let's keep things as simple as we can. So let's paste that in. All right, good. And let's limit 5. Okay, so now we're not returning. So that the query runs, but notice we're not returning any terms data in the result, right? So we need to actually go back and as part of our select statement, we need to add T.terms description. In fact, I'll add limit 5 here. Paste that in. Okay, here we go. Yeah. All right. So now we're getting all of our, or in this case, we're just getting 5, but we're getting all of our invoices. And in this case, we're returning invoice number, date, invoice total. We're returning the invoice name. And we're returning the terms description. Now, and again, I'm putting myself in a sort of real world scenario where I say, okay, a salesperson asked me for this query. Now, what I would do in the real world is often when I have a query, like at this point, I think the query is done, right? I'm like, okay, this all looks right, but I kind of like to say sanity check. So what I'm going to do is, again, I think this is the finished query, but I'm going to actually take and cut and paste this, and let me put this in chat. So let's say that's the finished query there. I'm going to make a copy of this because I just want to, I'm going to add, and what I'm going to do is add some fields here that are going to just allow me to sanity check the data I'm seeing, just to make sure it's right. So for instance, I'm making an assumption about the vendor name here, and I'm thinking to myself, you know what, I would actually like to see the vendor ID get printed out here too. I want to see the vendor ID from the invoices table, and then I'm going to actually run a query against the invoices table, or I'm sorry, I want to see the vendor ID from the invoices table, and then I'm going to take that ID and actually query the vendors table and just make sure sanity check the right name is showing up. So let's see what that would look like. So in addition, so what I want to do is when I print the query out, I want the vendor ID to show up here. And so I'm going to go up again. I'm not going to touch. This is the original query that I say I think it works. So I'm going to leave that one in place. And I'm going to add after invoice total, I'm going to actually add I.vendor underscore ID. And then I'm going to run that. All right, I see my vendor ID here. Now, again, this is just like, yeah, it's just a sanity check. It's just something I would do just to make sure. Now, I'm going to do select vendor ID from vendors where vendor ID equals 89. So I'm going to write that query out. Let me see if I can do it by hand. You can get it right. Select, actually, I want to select vendor name from vendors where vendor underscore ID equals 89. Now, if this is what I'm expecting to be, it should be this Evans excutone INC, right? And in fact, yeah, it does, right? So that's just a quick sanity check just to make sure, again, when you have a query like what we've got here, I mean, all this looks good, but you don't really know. I mean, you sort of know, but you know, you never know when maybe you could be this name could be pulled from some other table or some other source that you're not quite sure about. So that's just kind of one place where I would sort of sanity check the data in the query to make sure it's right. Greg, go ahead.
When in your code where you're writing like from invoices I or join vendors V, is that where you're creating the alias?
It is, yeah, and that's a little bit counterintuitive because it's like, well, you're using I up here, but you know you're setting it down here, but that's just the way it works.
And once you've done that, then you can use it. Yeah, every time you
Anywhere.
need to call it. Okay, all right.
Yeah, because right, if you notice, you know, we use the aliases up in the select statement, and then we also use them down here in the on, well, in the on and the join, and then the join clauses. So
Okay.
yeah, and that's really, I mean, that's kind of the big one. You know, again, on the sanity check side of things. I mean, terms description is not as a sophisticated things. I probably wouldn't worry about that. There's probably some more things we could do here. You know, again, just this idea of sort of testing the queries that we're running, but that, you know, I would feel pretty good about this. You know, I would feel pretty good about this query now and sending this back. You know, and again, in a real world scenario, you might be, you know, often what I get is I will run queries like this and I'll create a CSV file. There's an export statement you can do in a lot of tools where you can run a query like this and export the data to a CSV file and then send that over, and then your salesperson or your manager, whoever, they can open that CSV file in Excel, and then they can sort columns, and then maybe they can even run Excel functions to run their own queries. And again, these are pretty, you know, this is relatively small data here, right? I mean, you know, imagine running a query like this and getting 5,000 rows. I mean, I've got a database right now that I work with that, you know, often there's thousands of rows that get returned. So I'm often pretty humble, if you haven't noticed that yet, about this kind of stuff. And, you know, it's kind of the whole under promise over deliver kind of thing. I will often send a query like this, or I'll run the query, get the data. I may save it to a CSV, send it back to the sales or the stakeholder and say, all right, yeah, here, I think that this is it. You know, if you see any issues with it, let me know, because again, you just never know. Often too, the stakeholders really, they know the data in some ways better than you. Now they don't know how to run queries and do all that, but they have a better feel, you know, they have a better feel in general for the data, and so they may find issues with it. So you know what, you know, I'm seeing an invoice that shows up here when, you know, when it's not, maybe there's not a vendor name for it or something like that, and then you might have to sort of retool it. Andy, go ahead.
So in this query, you're referencing the aliases before you make them. But after you run this single query, can you reference them again by that alias, or do you have to do it every single time?
No, you have to do it every single time. You can look at queries as what's the term I'm looking for? They're sort of self-contained for lack of a better term. Yeah, you run them each time. Nothing's being saved. Now, later in the semester, we will talk about creating variables that are, I think persistent would be the word, that they live after a query is run, and then you can use them after that. But yeah, for things like what we're talking about here and aliases that are part of queries, they're sort of one-time use, just part of that.
So right now, to edit it, the most we could do was like copy and paste and then add something back in.
Mm-hmm. Yeah.
Okay.
Yeah. We'll talk about, we're not going to use MySQL Workbench and PHP MyAdmin this summer. If you take DBA 210, we'll introduce you to those tools there. Those tools make it a little, they give you a GUI interface, but it's still kind of the same thing. You still have to modify the query, rerun it again. So, I mean, the only thing those tools will give you over what we have here is, instead of having to cut and paste, but you've still got to modify any time you make modifications like that. You got to manually edit the text and then the query and then run it again. All righty, well, we're at 1 hour and 10 minutes. I'm gonna stop there. We had some more. Had some more examples we can do, but I think I'm gonna stop there. And you can see here. I mean, again, I sort of drug this out, and we got in the weeds pretty good. I mean, this, typically something like this might even take 30 seconds to do, but we sort of, painstakingly walk through each step. But I hope it gave you a window into. And again, I approach things from a real world standpoint, like in the real world, what the thought process would be like. Now, again, in the real world, might only spend a few seconds on each one of these steps, but again, it gives you a sense of what the mental process is like. Gregory, go ahead.
Two things. Can you drop the URL for the YouTube into chat?
Let me do that right now. Yeah.
Thank you. Do you have time to look at something that maybe can explain the ambiguity process?
Sure. Is there a suggestion you have, or you're asking me for one?
Oh yeah, you said that the one you were doing before didn't really work. I don't know if you
Yeah,
got time now or
I'm not
not.
saying nothing's jumping out at me. Here's what I will do though. I will, and I'll share it with the rest of the class. I'll put it in the class announcements. I'll come up with a good example, either make a video myself. I can probably find something online, maybe a short video or something that succinctly sort of explains what I'm getting at. Yeah, I could try and think through one now, but rather than you all seeing me sort of fumble through something to come up with something good, yeah, let me spend some time thinking about it and looking for something that makes sense, and I'll share that. I'll share that with you. And I will say too, we'll follow up. I know for sure in the database design when we cover chapter 10, we actually spend 2 weeks on that. That's the database design class. I know explicitly the video. I've got some videos. Well, I think my videos, and then I've got some YouTube videos, one or two there that I know explicitly goes more into this idea of ambiguity and making sure that the queries can't be ambiguous. So, but I'll come up with something now here in the next day or so, and I'll send that out. In fact, I'll do it when I share this video. When I share the video with the class, I'll just make it a part of that email. Okay. Any other questions? Okay. You all tell me, just send me a message if you want, if you have a strong feeling about it either way, and let me know what you think about doing this over Zoom. I mean, we'll probably do the in-person. We'll be back. We should be back next week. But I mean, I actually think, I was telling my wife this, like, man, I actually think I think the Zoom thing works fairly well as opposed to in class. I mean, one of the big advantages too is I think there's probably people that show up to this and watch this, or would attend the Zoom meetings that wouldn't otherwise show up to the live class. So anyway, that was just a thought that I had. Probably won't do it this semester, but potentially next semester it would be for sort of future use. But anyway, I'm just curious what you all think about Zoom doing something like this synchronously, so it's live, but having live Zoom meetings like this instead of in person or in class. But just you don't have to share it with me now. But just if you have a strong feeling about it either way, send me an email. All righty, that is it. Hopefully the weather will cooperating. We'll be back. We'll be back in person next week. I do have. Let me make sure because I am out Valentine's weekend. So yeah, right. I'm around. Next Monday is the 16th. I will be out of town then. So, but anyway, I'll send an email notification about that. So, all righty, sounds good. Again, if you have any questions, let me know, and we will see you online. Thanks.
Thank you, Professor.
Bye.
Thank you, Professor.